Hello and welcome to our first lecture of solving a linear problem using simplex method where we have inequalities of type greater than. First thing, what do we mean by an inequality of type greater than? It would be 2x1 plus 3x2 greater than equal to 10. So now what we see is we have an inequality which is of type greater than. Greater than meaning that this side LHS is more than 10, more than right hand side. If this side is more, if this side is having more weight, how do I make it equal to 10? I remove some weight, I remove something because this is more. How do I remove it? We get 2x1 plus 3x2, remove something to make it equal to 10. So this is how we make it equal to 10. I have removed something. Now suppose I had two inequalities, another would be 3x1 plus 5x2 greater than equal to 20. Suppose we had these two inequalities and let us take a Z-max also. Z-max would be, let's say, 40x1 plus 50x2, and instead of max let us say that this is min. Because we are just opening up the topic, we'll take a canonical form, semi-canonical, whereby we have a minimization with all greater than. True canonical was maximization with all less than. This is almost same. Maximization with all less than, if we flip it completely, it becomes minimization with all greater than. So let us take this very small example to understand the difference in formulation. As far as solving is concerned, we'll see it in next lecture. For now, let us see how the formulation is different. We have an objective function subject to two different constraints with physical constraint of x1, x2 being greater than equal to 0. This is the formulation part. So this is where the this is the problem that has been given to us. In problem we see that we have, so in problem we see that we have a minimization, greater than and physical constraints. Everything is same. Where are the differences? First step. Remember first step, what was that first step? Make decision variables and surplus is equal to 0. Sorry, not first step. This was the step that we use for IBFS. Make decision variables and surplus is equal to 0. So this is first time that I am using surplus. Okay. Let us convert this inequality into inequality. This one would be 3x1 plus 5x2 is equal to 20. Now this is also more than 20. So let me remove something from here. Now because I have two different surplus variables, let me give them some subscripts 1 and 2. 1 indicating that it is coming from first constraint, 2 indicating that it is coming from second constraint. And they look like S, but this time they are not slack, rather they are surplus. Earlier they used to be slack. In maximization with less than problems we used for less than inequality we make use of slack. This time also it looks like being same S1, S2, but it is not a slack, rather it is a surplus. Now how do we handle this surplus? S1, S2. Now what was my IBFS? Make all decision variables is equal to 0. Up till this point I used to do this. If I go ahead with this, my IBFS would be, this is 0, this is 0, minus S1 is equal to 10 or S1 is equal to minus 10, minus S2 is equal to 20 or S2 is equal to minus 20. This is a big no. Why is this a big no? You cannot have a negative starting point. IBFS cannot be negative. We cannot start with a negative solution for any variable. But in this case, obviously minus S1 will become equal to 10. So in order to avoid this negative start, what we have done is, remember we used to make this condition always decision variables and surplus. All decision variables and surplus variables should be equal to 0. Because if I do not make surplus variables 0, this becomes 0, minus S1 is equal to 10, S1 is equal to minus 10. So I am getting a negative start. But negative starts are not allowed. No variable in simplex solution can start with a negative value. During the solution, they might end up in negative values. I will reject them. But nothing can start with a negative solution. So what I am doing is, I am saying that make decision variables equal to 0. Also surplus variables is equal to 0. Now, when I tried solving the IBFS using the old known principles, I made a wrong start. Okay, no issues. Now I've learnt that surplus should also be 0. If I make decision variables and surplus 0, my IBFS becomes 0 plus 0 plus 0 is equal to 10. Second would give me 0 plus 0 is equal to 20, which again is a big mistake. How can 0 be equal to 10? How can 0 be equal to 20? Here comes our third variable, which always follows surplus. Surplus will always be accompanied with this. Artificial variable. Because surplus will always give you a negative start, and in order to avoid that negative start, you will always make it 0, and when you make it 0, you always get a wrong start, a mathematical fallacy. So what we do is, we make use of surplus along with artificial. Now what is this role of artificial? I will add an artificial variable. So this becomes a norm, this is a rule, that with surplus we will always have an artificial variable, because decision and surplus will become 0 and you will be stuck with a 0 equal to 20. So in order to avoid this contingency, what we are doing is, surplus is always coming with artificial variable. Now, this time, what was our first step? Convert inequalities into equalities. We have converted inequalities into equalities. In order to convert this greater than inequality, I had to deduct something that was a surplus variable. Surplus gave me a negative start, so I made it 0. When I made it 0, it became 0 equal to 10, so everything was a mess. So what I did was, I introduced artificial variables. Now, what is a slack variable? It is when you are falling short, I put in something. That is slack variable. Whenever you are less than, I put in something so that you become equal to that. That is slack. What is surplus? Whenever you are more than something, whenever you are greater than something, I deduct something. I deduct the surplus amount. I deduct the surplus amount so long as you do not become equal. So what is surplus? It is the amount deducted to make equal. So slack is done, surplus is done. Slack is when you are lacking something, I will put it. Less than, in less than type inequality, we were less than, I put it in. This becomes more, so I will deduct something, surplus. Now, what is artificial? Slack I can understand, I can explain you. Surplus I can understand, I can explain you. What is artificial? There is no explanation. As the name suggests, it is an artificial variable. It is not at all a variable. We have introduced it so that I could avoid that mathematical inconsistency that I have got. What was that mathematical inconsistency? 0 plus 0 plus 0 is equal to 20. So 0 is equal to 10, 0 is equal to 20. That was mathematical inconsistency. In order to avoid that inconsistency, I am adding artificial variable. Now what happens? What is my condition? Make decision variables and surplus variables equal to 0. If I make decision variables and surplus variables equal to 0, I am left with an IBFS. What will be my IBFS? 0 plus 0 plus 0 giving me A1 is equal to 10, A2 is equal to 20. This is my IBFS. This will be my first row, A1 and A2. You get IBFS. Now, also, this was one aspect. Second aspect, I've converted my inequalities into equalities. Next is incorporate all these variables in objective function. Earlier, I had only variables z, x1, x2 and everything was in objective function. But now I have x1, x2, s1, s2, a1, a2, all these should be brought into objective function. How do we go about that? Z min is equal to 40x1 plus 50x2 my variables. Then I need to bring s also, 0s1 plus 0s2. This is how we used to bring in s1 and s2 in Slack also. So I am multiplying them with 0 here also. No issues. There can be a confusion that, sir, this is minus. Why are you adding a plus? As it is being multiplied to 0. You could have put a minus 0 or a plus 0. It hardly matters. This complete term will be 0. So I have x1, I have x2, I have s1, I have s2. What about artificial variables? Plus a1, or rather let us say a1 and a2. These a1 and a2 are coming into my equation after being multiplied to So, the method of dealing with greater than inequalities is big M method. There is another method also, two-phase method. So, whenever there are greater than inequalities, whenever you come across greater than inequalities, even a single inequality, even a single greater than inequality, you either go to big M method or you go to two-phase method. Right now we are talking of big M method. First we'll talk of big M method. What is this big M? A1 and A2 need coefficients. Those coefficients will be big M. What are coefficients of x1 and x2? Their contributions. 40 rupees I make from table, 50 rupees I make from chair. So, my total profit will be 40 into number of tables, 50 into number of chairs. This is my contribution. So, x1 and x2 get coefficient of their contribution. S1, S2 may it be slack or surplus, it gets a coefficient of 0 because they do not contribute to my profit. S1, S2 leaving some units of hours, machine hours idle. Now, leaving some units of machine hour idle does not contribute to profit. Leaving some wooden blocks idle, not consuming the complete 100 wooden blocks, you are only consuming 98 wooden blocks and you are leaving 2 of those idle. This again does not contribute to your profit. So, because leaving anything or consuming more of some resource does not contribute to profit, what I am saying is leaving something unused or making use of more of a resource does not contribute to profit. What contributes to profit is selling of x1 and x2, selling of tables and chairs, not using wooden blocks, not using time, not using labor time, not using machine time does not add to profit. So, what we are saying is number of units of chairs, number of units of tables will contribute to my profit with their respective amounts 40 and 50. Unused or excess will not contribute to my profit. What is slack or surplus? Either less than or greater than amount, either unused amount or less amount. They will not contribute to my profit. What about A1, A2? I am multiplying them to M. What is this M? This is a big M. What is this big M? What is this big M? What do we mean by big M? A number much larger than any number in problem. In my LPP, what is big M? It is a number much larger than any number in my LPP. What are the numbers in my LPP? There is a 40, 50, 10, 20, 3, 5, 2. These are the numbers in my LPP. So what will be M? It will be much larger than this. It could be a 10,000. It will not be a 50 or a 70 or a 80, because 70, 80, 100, these are also greater than 50. If I take 100, if I take M as 100, it is greater than 50, but it is not much larger. Much larger means that it is clearly very big as compared to any of these numbers. Let us take it 10,000. Or for that matter, let us take it 5,000, 2,000, 1,000, because 1,000, 2,000, 5,000, any number would be very big as compared to the largest number that we have. Largest number that we have is 50. So what is big M? That M is a very large positive integer, larger than any of the numbers that we have in our solution, in our formulation. So big M is very large number. You need not put a value on it, but to understand, it is a very large number. So the big M. Now what about the sign, plus or minus? This is minimization problem. Leave it. Let us talk of maximization problem, because up till this point we have talked of more of maximization problems. Suppose I have a maximization formulation, leave this, forget this. Suppose I have a maximization formulation saying 10 x1, 20 x2, 0 x3, minus 5 x4, minus 100 x5. Suppose these are, what is x1? Number of units of product A. Now understand this, what is the role of A, what is the role of sign, what should be the sign, minus or plus? Understand it very carefully. x1 is number of units of product A, x2, x3, x4, x5. Number of units of product B, number of units of product C, number of units of product D, number of units of product E. Suppose I am producing all these products. I am producing product A, B, C, D, E. What will be my total profit? My total profit will be profit coming from A, which this suggests that it is 10 rupees per unit of A. So I am making x1 units of A, so my profit will be 10x1. I am making x2 units of B, so my profit will be 20 into x2. 20 is the profit coming from 1 unit of B. Similarly, x3, it is not contributing to any profit. It is not giving me a loss, it is not giving me a profit. It is a product that I am manufacturing and selling cost to cost. So it is not giving me any profit. So it is giving me a profit of 0. What about x4? Number of units of product D. Now, if I produce 1 D, it actually gives me a loss of 5 rupees. Probably it is a product which is outdated. I am producing, but it is not selling. I am just keeping it alive because there are some customers who have ordered it. Whatever X, Y and Z reasons. X4 is number of units of D, and it is actually giving me a loss of rupees 5. Same is with E, it is giving me a loss of rupees 100. So now, do we understand what this objective function is? Objective function always tells me the number of units of different items that you are making and their respective profit. I am making x1 units of A and its profit is 10 per unit. So the total profit becomes 10x1. Suppose I make 3 units, I will get 30 rupees profit. If I make 100 units, x1 is number of units. If I make 100 units, I will get 1000 rupees profit. So the objective function is framed in such a way that we have number of units of different products, different combinations and their respective contributions. Now the $1 million question. Which product would you love to manufacture? Which product will be your best choice? If there are no constraints at all, I am not saying produce this, I am not saying produce that, you are left alone, you are the manager, you are the marketing manager, you are the CEO, you are the boss, you are the owner. Which product will you manufacture? No constraints at all. Definitely you will produce X2. Your first choice will be X2 because a single unit of X2 gives you 20 rupees. If you produce X1, that is product A, you will get only 10 rupees. So you are getting double the profit in product B. So what you will do is, you will increase X2. You will produce only B because by increasing X2, you are increasing this 20. So your first choice will be X2. What will be your second choice? When I have exhausted this, if I put some pressure on you that no, you have to produce one more product, I need variety. It will not do by making only one soap. You cannot go on producing only A, only B, 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 B. You need to produce some other soap also. Which soap would you produce? Type A, B you are doing, A, C, D or E. A, C, D or E. Which soap would you love to produce if there is a pressure on you to produce two soaps? Your second choice would be X1. Why is X1 your second choice? Because this is giving me 20 rupees, left alone, I would only produce this. But if there is a pressure, someone says that you have to produce two soaps, two varieties of soaps, okay, I will produce this one also. Now the pressure comes, you need to introduce a third variety also. You need to produce a third variety of soap. What will be your obvious choice? It will be X3. Why X3? Because if I touch X4 or X5, they will actually take my profits into negative zone. So what I will do is, I will stick with X3. It is not giving me profit, but at least it is not giving me a loss. These will in fact give me a loss. So if I had only one choice, I would produce X2 because it has most positive. If I was forced into second choice, I would go with X1 because it is still positive. If there was further pressure, I would go to X3, which is 0, no profit, no loss. But what if someone pushes me still further? You have to produce a fourth breed, a fourth brand, a fourth kind. Then what do we do? Do you go with X5 or X4? Do you go with D or E? Which one would be better? Obviously, X4 would be better. Why? Because 1 unit of X4 will eat up only my 5 rupees of profit. But 1 unit of X5 will eat up my 100 rupees of profit. So, my next choice will be X4, and then if someone pushes me further, then my last choice will be X5. Now, this was a very important example. What is objective function? It is accumulation of contributions of all different products. I had different products A, B, C, D, E. I had their quantities and their quantities multiplied by their profits. What were the profits? 10, 20, 0, minus 5 and minus 100. These were their respective contributions. So, total profit would be 10 into X1. Profit coming from B would be 20 into X2, 0 into X3. So, objective function is an accumulation of profits coming from all different products. Looking at the objective function, I can tell that I am getting a 10 rupee profit from here, 20 from here, 0 from here. I am in fact getting a loss of 5 rupees from fourth product, loss of 100 rupees from fifth product. So, are we clear with this formulation? Are we clear with this priority? Why I am getting this priority? Because this is the most positive. If it is a case of maximization, I will run to this. It is most positive. Why is X1 is in second spot? It is at least positive. Everybody else is 0 or negative. So, first choice, second choice. So, most positive is my first choice. Who is my last choice? Least positive. If there were a 500 X6, I would go to X6 in last. If there was a 100 X0, I would run to that X0. So, the idea is when we are trying to maximize our returns, when we are trying to maximize our profits, my first choice is most positive and my last choice is most negative. When there was only x5, 100 was most negative. x6, 500 becomes most negative. Last choice is x6. So, do we get this idea that for maximization, most positive is first choice, most negative is last choice. Most negative is last choice. This is the reason. What I'll do is, okay, before getting into this problem, are we clear with this? So, in max, first choice is most positive, most positive, last choice is most negative. For max, we have choices of most positive and most negative. What happens with minimization? If it were a minimization problem, here I needed it to be maximum. If it is a minimization problem, I would love to have minimum value. Who will be my first choice? Because 1 unit of x5 will take me to minus 100. This time I am trying to minimize my solution. This will give me the least possible solution. So, my first choice becomes x5. Second choice would be x4. Third choice, do we go with 10 or 20? They will actually increase my solution. I wish to decrease, I wish to minimize. So, third choice would be x3. Fourth choice would be 10 or 20? Only 10, because x1 will only take me above by 10, but x2 will take me above by 20. So, my next choice would be x1 and last would be x2. Now, if we see here, we had x2, x1, x3, x4, x5, x2, x1, x3, x4, x5. Exactly opposite choices. From here we will derive a rule. From here we will derive a rule, and that rule would be okay, this is the objective function. X have come, surplus variables have come. Now, we have decided that I will multiply this a2 to a very large positive integer, and as it is a minimization problem, what I will do is I will make it positive. Because what minimization loves is smaller values. Minimization loves smaller values. Minimization would love these values best. Then if pushed further, minimization would go to x1. If pushed further, it will go to x2. If pushed further, then it will think of a1 and a2. So, what I am trying to do is, in minimization, by making them positive, and positive huge, very large numbers. Imagine, I told you, this is a number larger than anyone. It could be 10,000, it could be 20,000, anything. This is a number larger than any number. Now look at this equation. What will be my first choice in case of minimization? These will be my first choices. Second choice, third choice. These will be my last choices. What I want to do is, I want to keep artificial variables out of my choice. I do not want to select a1 and a2 because these are artificial variables. I have no clue what these variables are. So, what I wish to do is, I wish to keep them out of my solution. How do I keep them out of my solution? For a minimization problem, you give them a very huge large number, very huge positive number, plus m. And if it has been a minimization problem, if this maximization problem, if it were a maximization problem, what would I do? Z max is equal to 40x1 plus 50x2 plus 0s1 plus 0s2. Now, because it was a maximization problem, I would give it a very negative value. minus m a1 minus m a2. Because maximization loves positive values. First choice, second choice, third choice, fourth choice, and these would be the last choices. What I am trying to do is I am making them last choices in minimization also. Minimization just hates the big values, big positive values. So it will hate these plus m values. So it will hate to come to a1 and a2. What it will do is it will roam around in these four. It will not come to a1 and a2 because it does not like positive values. Same is with maximization. Maximization loves large values. So maximization will run to these values, but maximization will avoid a1 and a2 because it loves large values. It loves maximizing the solution. But these are bringing me down. This is minus 10,000 per unit. Minus 10,000 per unit of a2. It is a huge setback. So maximization will avoid going here. Why I am avoiding going to a1, a2 here also and here also? Because these are artificial variables. I myself have no clue what these variables are. Why have I taken these variables? I have taken these variables to avoid this inconsistency. Inconsistency that was creeping in. First was S1 is equal to minus 10. First problem was I was getting a solution of S1 is equal to minus 10. That I avoided. How do I avoid that? Decision variable and surplus. If I only go with decision variable equal to 0, I was getting minus S1 is equal to 10 or S1 is equal to minus 10. In order to avoid that, what I did was I changed my condition. Decision variables and surplus. Decision variables and surplus are equal to 0. So that made 0 is equal to 10. In order to avoid that inconsistency, I introduced artificial variables. Now I have no clue what these artificial variables are. Slack I very well know I am putting in something. Surplus I very well know I am removing something from the heavier side. The larger side I am removing something. But what about artificial? I have no clue. And because I have no clue what artificial variables are, I try to avoid them. How do I avoid them? By giving them a very big plus m in minimization and a minus m in maximization. This is the big M method. Big M method. To summarize, what is this big M method? This big M method is multiply plus M in Z max. Multiply minus m in Z max and plus m in Z max. Minimization wants smaller value, so I am giving a huge value. Maximization I want huge value, so I am giving a very negative value. Now because I am giving them the opposite of their choice, they will reject this A1. They will not like this A1 and A2. And when they will reject it, it will be out of my solution. Because if it comes into my solution and someone says go and produce 10 units of A1, I have no idea what is 10 units of A1 because I have no idea what A1 is. So what I am trying to do is I am trying to tell the solution that this is a thing that I least desire. I do not wish to make A1 and A2. So they will be rejected. How do we reject them? In maximization case, take minus 1. In minimization case, take plus m. In minimization case, take plus m. So this was it about the differences in solutions, and we'll talk more about this big M method when we try to solve certain questions. For now, just remember that the surplus are coming negative, and if I do not make these surplus 0, they'll give me a negative start. S1 is equal to minus 10. In order to avoid that negative start, I have put this condition, decision variable and surplus 0. If decision variable and surplus are 0, then 0 becomes 10. So in order to avoid that inconsistency, I have added another further variable, artificial variable A1 and A2. So my IBFS would be A1 is equal to 10, A2 is equal to 20. A1 is equal to 10 because I have made decision and surplus. Decision and surplus 0. So A1 becomes 10. Decision and surplus 0, A2 is equal to 20. What about my simplex table? Simplex table comes from objective function. We will have an x1, x2, s1, s2, a1, a2, b and theta. What is my IBFS? A1 is equal to 10, a2 is equal to 20. This is my IBFS. Objective function now contains all variables. It should always contain all variables. Earlier there were only 2 variables, it contained those. In previous questions there were only slack variables, it contained those up till this point. Today we have artificial variables, it contains all those variables also. So these are my variables. What are their contributions? Their contributions are 40, 50, 0 and 0, m and m. These are their contributions. Here we have contribution of A1 which is m, m. Here we have our constraints which is 2, 3, minus 1, 0, 1, 0. Then we have a 3, 5, 0, minus 1, 0, 1. This will be our initial simplex table which we will try to optimize upon in our coming sessions, in coming lectures. So for now, we have our formulation. There is a greater than sign. I add surplus variables. I add artificial variables. I include those surplus and artificial in my objective function by multiplying surplus by 0 and artificial by plus m or minus m. If it is a maximization, minus m. If it is a minimization, plus m. Because this is minimization, I multiply my artificial variables to minimization, I multiply them to plus m. This is my initial simplex table. IBFS is A1 is equal to 10, A2 is equal to 20. These are my constraints and we can go ahead and solve them in very similar way, Cj, Zj. Remember in the start of this lecture I told you that this min, what is effect of min? Effect of min is that we will take Zj minus Cj. Instead of taking Cj minus Zj, Cj minus Zj in case of max, today we are talking of min, so it will be Zj minus Cj. Remaining everything is same. There will be no changes at all. So, in order to proceed with big M method, we should be knowing simplex very well. If we know simplex very well, this is the only difference, artificial variable. Except for that, everything is same. We will talk about this in lectures to come. This was it for the introduction of big M method. Why this is called a big M? Why we are making use of plus m in minimization case? Why we are making use of minus m in maximization case? So that we can reject them. These are artificial variables. I do not want to solve them. I do not want to entertain them. I do not want to produce them. I want to reject them. How can we reject? If someone is talking of minimizing something, give it a big value. Nobody will like it. If someone is talking of maximizing something, give it a negative value. Nobody will like it. If someone is talking of profits, I say this will give you a loss of minus 100, a loss of 100. Nobody will like it. So this is the idea of plus m and minus m. This is the idea of big M method. So hope this helps. We'll talk about this method. We'll work on this method in lectures to come, where we try to solve linear problems with greater than signs. Now, if there are any queries, if something is getting confusing, if some issues are remaining unresolved, you can leave them in comment box. Do like and subscribe this channel if you have not already done so. And thanks for watching. Bye bye. Take care.